All right, so section 3.4, and we're just going to do a couple. These are just a couple of application problems, and these would be something more of what I would be maybe ask you these type of problems on a test. Some that you've seen. I'm not going to throw in one that you have not seen before. All right, so don't panic about that. But the ones that I show you are probably the ones that I think are important for you to know. And I'm just going to do two of them with you today. So a farmer wishes to enclose a rectangular region. Now, again, we're going to be talking about quadratics on this. That's what chapter 3 is about. He has 120 feet of fencing and plans to use his barn as one of the sides as an enclosure. Okay, so let X represent the length of one of the parallel sides of the fencing. So you got to kind of think about a picture here. Okay, so a picture would be, here's your barn. All right, so I'm going to make it wavy, even though a barn's not wavy, but just to recognize the difference. And then here's your other three sides. So it says the parallel sides right here are represented by X. All right, and so how much fencing does it say that you have? Well, it says you have 120 feet of fencing that would cover this, this, and this. And I don't need fence over here, right? Because that's the barn. So here, what would this be? If I know the total fencing I have for all three of that would be 120. If I took 120 and I subtracted these two sides, would you agree that would leave me with whatever fencing I need for this? So if I took away this X and I took away this X, then whatever's left, that's the fencing I'd have here. So that's probably the part that you need to be able to set up, okay? So determine a function that represents the area of the region. So how do you find the area of a square or a rectangular region? It's length times width. So let's put that into a function form. So f of x, you can use whatever variable, p of x, t of x, whatever you want. And we're going to do that the length times the width, okay? Or the length times the width, whichever way you want to show it there. So we're going to take 120 minus 2x times x, right? Length and width. So now this is, you want to keep it like this also, but to determine the function, I want you to go ahead and multiply that through. But you need to show this also, because that's going to come in handy in the next part. So if I multiply this x through, I would have 120x minus 2x squared. So let's just rewrite that as a function. Writing our highest term first, right? So we're going to do that negative 2x squared first, plus 120x. All right, so this is the answer to A. Now, what are the restrictions? So this is saying, so I can't have a side less than 0. Would you agree? So that would be a restriction. So the restrictions are just by taking these parts and setting them from your original and making them greater than 0. So x is greater than 0, can't do any more than that. So let's solve this. So this would subtract 120 from both sides. Now what happens when I divide by a negative here? If I divide this by a negative 2, okay, that means I have to flip the signs. You got to remember that. Flip the sign. This negative 120 divided by negative 2 is 60. So when I put that in interval notation, I'm going to say it's greater than 0, but it's less than 60. That's the restriction that I want in interval notation. Okay, so set them greater than 0, because both sides have to be greater than 0, and then solve that, and that's how you're going to end up with this inequality. I'm sorry, with this interval. So what's the maximum area a farmer can enclose? Well, let's bring our function down here. So remember when we talked about finding, when we have a quadratic, which is a parabola? Okay, how do we find the maximum or the minimum? Well, it's the vertex, right? So we know this opens down, so we know we have a high point, which is going to be our maximum. So how do we find that maximum? Well, we just find the vertex, because whatever the y value of the vertex is, that's your maximum. So let's find the vertex. So that is by taking the formula, remember, negative b over 2a. So a negative 120 over 2 times A. So this is a negative 120 over a negative 4, and that's going to be a positive 30. So that's the first part. Now let's find the second part by substituting it in right here. So if we find what 30 is, if we put it back in here, we have a negative 2 times 30 squared plus 120 times 30. So let's see, this is 30 times 30 is 900 times a negative 2 would be a negative 1800 plus 120 times 30 is 3600. So that's 1800. So 1800. So what is the maximum we are talking about feet? It's this right here. That's our vertex. It's the y value of our vertex. So the answer is 1800 feet. So isn't that kind of cool that you can find maximum areas by using quadratics? That's the most amount of fence that I can, that I will need to do that. So I think that's kind of a cool application problem. So you'll have one very similar to that. So just be sure you practice that a little bit, okay? Now, the next one is dealing with the Pythagorean theorem. So Pythagorean theorem, a squared plus b squared equals c squared. If you've forgotten that. And that's only used with right triangles. Okay, that's the only time that we use Pythagorean theorem is when we have right triangles. So let's go ahead and talk about, get this kind of figured out so it's a little bit straighter for you. Why is that not? Oh, okay. It's this hand-eye coordination thing. All right, so a piece of property is in the shape of a right triangle. So here's our property. Okay, and we know it's a right triangle, tells us that. The longer leg is approximately 20 meters longer than twice the length of the shorter leg. So one of these is the longer leg. It doesn't matter. All right, this is the longest side, but these are your legs. Oops, these are your legs. And this is the longest side, but they're talking about the longest leg. So it doesn't matter which one you choose. It doesn't matter. Mine look exactly the same. So the shorter leg, one leg's always going to be equal x. One's always going to equal x. Usually it's the shorter leg, but there's always one that's going to be x. So the other leg, the longer leg, it's approximately 20 meters longer than twice the length of this. So 20 meters more than twice this. So how would I say twice this? 2x. And then 20 meters more plus 20. The length of the hypotenuse is approximately 10 meters longer than the length of the longer leg. Okay, so here's the longer leg. And then I want to say even 10 meters longer than that, so plus 10. So this is going to be 2x plus 30 for this side. Okay? All right. So now it says find the lengths of the sides of the triangular lot. So all we're going to do is Pythagorean theorem. So this is just multiplying. So we have A and B doesn't matter, which the main thing is that, you know, this is C. The hypotenuse is always C. So A squared plus B squared is equal to C squared. So the biggest error you're going to find is if you can't multiply binomials using the FOIL distribution, however you want to do it. So this is saying 2x plus 20 times 2x plus 20. Okay. So this is going to be 4x squared. Okay, then I'm going to have a 40x and a 40x. And this is what's kind of interesting as a shortcut here. If I know, I just take this times this is 40x and I double it, and that's what my next number, that's what this is going to be. Notice this is, if I take this times this is 40x, this times this is 40x, so I'm going to have 80x. All right, so maybe I'll just write that out for you. Plus 20 times 20 is 400. So what I'm saying is I can do this distribution, right? And I can take the outside term, the inside term, that's what these are. Or I can say, okay, first term squared, multiply these together. That's, would you agree if I multiply that? That's a 40x. And I take it times 2. I always double it. and I'm going to have an 80x, which is what I have here, and then square that. So we'll practice that on the next side. Oops, so this becomes 5x squared plus 80x plus 400. So let's practice this over here. Now this is only if it's written like this, if it's exactly the same thing. If it's times itself, this is the only time this works. So we multiply, the first term is 4x squared. I multiply these together and get 60x, and I double it. So that's 120x. And then I square the last number is 900. And that's just kind of a shortcut if you're taking a binomial times itself. Now, if you don't want, just write it out and do the FOIL and the long term. That's totally fine. That's fine too. All right, so here, let's get our x's, let's get everything together on one side so we can solve it. So I'm going to subtract 4x, all right? I'm going to do this all in one step. So subtract 4x, I'm going to subtract 120x, I'm going to subtract 900. So minus 4x squared minus 120x minus 900. And let's see what we get. We're kind of running out of room. I'm not going to do this last problem, so I'm going to bring it down here. All right. So 5x squared minus 4x squared is 1x squared. 80 minus 120 is a negative 40x. And 400 minus 900 is a negative 500. And it's all set equal to 0. So all I did is get everything on one side here. Okay. Just did it in one step. So what are factors of 500 that I could get 40? Well, how about 50 and 10? So it needs to multiply to a negative 500 and add to a negative 40. So we have a negative 50 and a positive 10. So if I set each of these equal to 0, this becomes x equals 50, and this x equals a negative 10. Well, we can't have a negative side of a triangle, would you agree? So this one won't work. So I know that this is what I want to use. Now the question says, find the lengths of the sides. So we know that one side is 50, and don't forget to label 50 meters. Okay, now this one I'm going to put a 50 in. Okay, the 2x plus 20, we'll put a 50 in there. And that would be 100 plus 20, so that's 120 meters. That's the second side. Okay, the third side is 2x, which is 50, plus 30. It's really 10 more than that, so 130 meters. So those are the answers to the three sides of the lot, the triangular lot. All right, so there's a good example for you to be able to do that type of a problem. All right, I was going to do a volume problem with you, but I think we'll hold off on the volume. I don't think you have one like that on MATLAB, but remember that volume is length times width times height. If by chance you run into is length times width times height. I don't think there's a volume problem on there though, but anyway, just so you know that. All right, guys, that's all I have for you today. So thanks, and have a good day.